Happy Tuesday. Area between curves. This is the last thing that will be on the test. After this, I'm going to look at some techniques for integrating trigonometric integrands, which we'll cover again in Calc 2. And maybe look at some more functions that result in inverse trig functions. And of course, this light bulb is garbage. This region shaded. That's very difficult. All right, so let's say we want that area. Well, the process should be fairly straightforward. We would know how to find the area under F, right? What is it? How would you find that area just under F?
What's the integral in the region bound by A and B?
Of what?
The integral of F.
It's just the integral of F, right? And that gives everything. But we also know what this area here is, right? How did you find that area?
That's the integral of G over the area bound by A and B.
So then wouldn't the total area be the area under F minus the area under G? Let's make this a little bit clearer as well. That's the area we're looking for. But the integral is linear, isn't it? So that could be combined into a single integral. now I want that area. You had your hand up?
Yeah.
Huh?
Right minus left.
What do you mean right minus left?
There's a function that's to the right of that area minus the function that's to the left of that area.
What about that difference?
Oh, that's the area between groups.
You're saying the area right, area left? The right function minus the left function?
Yeah. The
That's what I was trying to get. The integral of that. Oh, yeah, help if I was actually back on. Still larger minus smaller. And then integral over the interval.
Do we necessarily have to put the larger first?
Yes.
We do.
Yes.
Okay.
Otherwise you get negative.
Well, my thought process was at the end we would just throw in an absolute value, so no matter what, we have a positive area.
You could.
Okay. So the math won't change, it's just an extra step at the end. All right.
In fact, if the region's split, ultimately it is just the absolute value of the difference, in which case order doesn't matter. But then you have to split it up, and we'll see that. Right? But for now, yeah, it's always going to be larger minus smaller for the reasoning that was in the previous slide. Right? When you take that larger area, subtract it from the smaller area, and that gives you the area in the middle. The area of the region between y equals sine of x and y equals cosine of x from x equals 0 to x equals pi over 4. So there is the region. Call it regional. So we're trying to find the area of. Let's first set up the integrand. Which is the larger function?
Y equals cosine x.
What are the limits for integration? Zero to what? Fundamental thing of calculus. First, we find the simple antiderivative. What's the simple antiderivative here?
Negative sign minus both.
Sine of x plus cosine. Cosine of x.
You took the derivative. Sine of pi over 4 is what? What is sine of 0?
0, 0.
Cosine of pi over 4. Cosine of 0. And how's that simplified?
Square root of 2 over 2 minus 2. No, square root of 2
What is it?
over 2.
What is it?
Is it already?
That can be simplified.
Square root of 2 minus 1.
Just root 2 minus 1.
I was just trying to simplify that bit in parentheses.
Which is what, about 0.41? Area of the region located between y equals 6x minus x squared and y equals x squared minus 2x. already notice a difference, aside from it not being trig. What is it?
You don't have like this specific like area in which to-
They didn't give you an area interval, did they? Well, they actually did. They just didn't explicitly give it to you. Alright, so first, let's just plot. Since we don't have an interval, we're going to choose one. We want x to go from
5 to 6.
Let me tell you right now, that's not going to work.
Why would you choose the interval?
Because they didn't give us one.
Yeah, but can't you just see where they?
I can, but I want to get an idea of the region first. So I'm just going to plot first and then deal with everything else.
But can't you just set it equal to each other and see?
I could. But I want to get an idea of the region first.
And it says interval. I gave it an interval.
5 to 6 won't work.
0 to 10.
0 to 10 might work. I'm trying to get a picture of the whole thing. So I also want some negative values. Unfortunately, I don't think that's going to be nice. I think I have to adjust the range as well. But we'll see. Not sure how I feel about that.
So we just set them equal to each other to find the intersection points and just find the area between that.
So that wasn't good enough.
Because the ones on the x-axis we have both by certain amounts of the both.
I'm just trying to get a better picture of the region. Trying to find a good viewing window. Okay, that looks kind of good. Right, pretty obvious that is the region we're looking at, right? So yeah, we need the points of intersection. You find that by setting them equal to each other. Do not read it from the graph. Graphs are not necessarily drawn to scale. So while yes, it does look like it's going to be 0 to 4, always verify that algebraically. Remember how to solve an equation like this?
you end up getting 2x squared plus 8x equals 0, and you can factor out 2x.
So what did you do?
Well, you gotta get everything on one side.
And set it equal to 0, that's called a quadratic equation. Right? In general, that's what you always want to do. And it doesn't matter which one. Let's avoid the negative, so I agree with you. Oh, that's nice, there's no constants. You factored out a what?
You factor out 2x,
Be left with what?
x minus 4. X would equal 0 on the board.
Why?
The 2x, well, if you separate them, x minus 4 equals 0. So that would just be simply x equals 4, and 2x is effectively that right thing multiplied to nothing, which would make it 0.
Do you remember why you set each one individually to 0?
Well, whatever the degree of the leading coefficient would be, that's how many zeros you're going to have.
True.
In this case, there's
But that is if you also consider complex zeros. X squared plus 2 equals 0. You're right, it has two zeros, but they're both complex. So they don't have to be real. And since we're only looking at real solutions, that is not really a good gauge.
I think
To go
I know
by.
where you're going with this. Whenever we have an equation that consists of multiplying two terms together, we want that to equal 0. That happens when either of those two terms are equal to 0, so we have to solve for both cases.
What is that called?
I don't remember the fancy name for it. Principle of something, I'm sure. I don't know.
Not principle. Does begin with a P. Well, one of the terms does. It's called the zero property. States if we multiply real numbers together and get 0, then at least one of them has to be 0. Corollary to that is if you multiply real numbers together and you don't get 0, then none of them can be 0. Confirmed. 0 and 4. But let's say we're feeling particularly lazy. And we don't feel like doing it by hand. This is not algebra. I don't care if you can solve an equation by hand. I care about the interpretation of it. Menu, algebra, solve. Type in the equation. X minus x squared equals x squared minus 2x. And then you need to tell it to solve with respect to what variable? X. Enter. And we get our two solutions, 0 or 4. I'm not sure if solve will actually give you complex solutions or not.
Try x squared plus 2.
I'm not sure if it will. I know CSolve does. Good, it doesn't. So you don't have to worry about that. This will only give you the solutions we're interested in.
I mean, I feel like if we saw an I in the answer, we'd know to avoid that.
Yeah, but better to just not even have it.
Yeah. Yeah, this is good.
If for some reason you do want complex solutions, you have to go to complex solve, which is called CSolve. That will give you all the complex solutions, which does include reals, by the way. All real numbers are complex.
Yeah, I guess it would be close to 0 on.
Yes, that's why. Every real number is a complex number.
What do you get this software, by the way?
Comes with the calculator. Well, let me rephrase that. This is the teacher software, which you don't have access to.
Right.
The student software comes with the calculator. When you open it up, you should get a card with a license code on it.
Got it.
There's one problem with that code. It's not transferable. Which means if you get a new laptop, you just lost it. You have to buy a new license. Which is annoying,
I think I'll stick with single lag.
but there you go. But this is just useful for me to show you how to do it on a calculator. Now we have our points of intersection. We can set up the area. Integrating over 0 to 4. Which is our larger function over this interval?
6x minus x squared.
Let's say you didn't have access to the graph for some reason. How would you be able to determine it? So how could you do it algebraically?
I couldn't choose plugins. I guess.
Well, if you plug in 0, you're going to get them equal to each other.
Yeah, if they had a constant, or sheet just set up. If you had a constant, it was like 6x minus x squared plus 1 or something. And the other one didn't. The other one had a lesser constant. Your sheet just set it to 0.
Set them to 0.
Or not set it to 0, plug in 0.
Well, if that was the case, then this probably wouldn't be our interval. Right, you can't use the endpoints because they're going to be equal at the endpoints. But what can you use?
So we know the endpoints are only intersection points. So they don't intersect anywhere in between, so let's just pick a value somewhere in between.
Pick a number between your 2 endpoints. In this case, 1 would work. Right. The example you were using, I think 0 would be in the interval, so you could use 0 in that case. But the idea is you pick a test point. Remember we were doing that, test points? Pick some value in your interval, plug it in. Whichever one's larger is your larger function. 6 minus 1 versus 1 minus 2. 6 minus 1 is larger, so that's your larger function. So this is going to give us 8x minus 2x squared dx. Now I have to solve that. Thankfully, it's an easy one. Shame it's not Calc 2. Calc 2, I'd let you use a calculator to evaluate that. But you don't get that luxury. You have to do integrals by hand. What is the simple anti?
4x squared minus
0 to 4. 4 squared. 16 times 4. And of course, that's 0. It's 0, so I don't care. 4 cubed times 2. Oh, well, here comes the fun part. 64 times 3. 180 and 12, 192. Minus 128. There's your area. If you wanted to, you could write square units, or units squared or whatever. We don't know if they are, but I'm not going to make you do that. If units are given in the problem, then you would have to include them. Want the area of the region between the parabola y squared equals 4x, bless you, and the line y equals 2x minus 4.
Well, first things first, can we rewrite the parabola as y equals the square root of 4x?
Can you?
Well, yeah, I'm just asking if we could.
That's what I'm asking you. Can you?
Yes.
Why can't you?
It's in terms of y. It's going to be a parabola on its side.
If you just do y equals square root of 4x, it's not a parabola, is it? You gave me half of it. If you want to use the plot feature, I think I'll show this here. Control 0 to get the graph. Y squared equals 4x. If I just do square root of 4x, that's what you get. It's clearly not y squared equals 4x. But we can still do it. You'd have to plot both positive root 4x and negative root 4x. That would get you y squared equals 4x. But that's really messy. There is another option. Menu, graph entry, relation. That works. But we have another one too, don't we? We have that line as well. Those labels do get in the way. Thankfully, we can move them. Not as easy on your calculator because you don't have the nice mouse. You have to use the actual mouse pad, which is very tiny on the calculator. It's definitely difficult to do. Your best option there is just to click it and then hit delete, just to get rid of it. Also, bear in mind, the scaling for this calculator is off. It would not look right if I did try to do a -10 to 10 viewing window all the way around, because of the way that the y-axis is scaled versus the x-axis. I don't know why. There it is. I don't actually know how the scaling works on the calculator itself. I don't know if the scaling is the same. I don't ever use that. So instead, we're going to do it on Mathematica. Again, I could use the plot feature. I'd have to do the two functions y equals square root of 4x and y equals negative square root of 4x. If I want to use relations, then I have to use the contour plot command. And don't worry what a contour plot actually is. You studied that in Calc 3. For now, it just lets us plot relations. Yeah, 2x minus 4. Again, we weren't given an explicit interval. So I'll just do the standard -10 to 10 viewing window all the way around. The only problem with the contour plot is I've now lost my labels feature. I can't actually label my curves, which is a bit of a pain.
Weird thing to not have.
The only way I can do that is to have different colors for each curve. And then use the plot legends command or option. And what it'll do is, oh yeah, I have to fix that too, is give me the lines out here and say what each color represents. So I think that's what I'm going to do. But notice, contour plot puts it in a box, a frame. I don't like that. That's okay. Because I can turn the frame off. But now look what it gives me. That's not very helpful.
Yeah, and I think you lost the numbers too.
Because the frame went off. Turn the axes on. There we go. That looks better. And just because I'm so used to having them, you really need them in Calc 3. Put the labels on as well for the axes so I know which is X and which is Y. I could change the colors because, I'm sorry, the mathematic default colors are just so ugly. Those are just hideous colors. That yellow looks like a puke yellow on my screen. And the blue is a very dull blue. It's just hideous.
Why are you insulting cornflower blue?
It's hideous. I don't know why they don't just use the default blue and yellow, why they have to use those hideous dulled out colors. Although, the yellow will work. Oh wait, will it? on my background?
Uh,
That's bright enough, it should show up. Let's find out.
Well, won't it have a white background?
Oh, if I do copy as an image, yeah.
Yeah.
And the region is obviously right here.
That's what they bring to the wages.
Define the you select both X instead, as opposed to Y, because we're on the Y.
You could.
Did you set 2x minus 4 to square root of 4x and negative square root of 4x to find the top and bottom intersections?
You could.
Well, similar to what Jake was saying. The first y squared equals 4x is within respect to y. So since we're trying to integrate in terms of the x-axis, wouldn't we want to set that in terms of x by substituting y equals 2x minus 4 into y squared?
You could.
Factoring that out, get a factor, set them equal. Then you'd have your intercepts, that would be your bounds.
You could do this with respect to y instead. That would actually be the easier option. I'm not going to go that route for a reason. I'm going to do both. I'm going to do it with respect to x and with respect to y. So for now, hold off on the y. Let's just say we're doing it with respect to x. Probably the easiest way would be to go y equals this, right? 2x minus 4 quantity squared equals 4x. And then solve. So give you a quadratic. I'll let you verify it. You get 1 and 4. What's our actual interval? So I'll show you what 1 to 4 gives us. One to 4 just give us that area. It's not the area we want.
you just use two separate integrals?
Gonna have to. You're gonna have to. Hmm? I'm doing it with respect to x, not y. So what's that first interval?
That's just from 0 to 1.
That's 0 to 1. That is easy to determine by looking at y squared equals 4x. 0, 0 is where they would be equal. 0 squared equals 4 times 0. And of course, notice that x can't ever be negative, because then you'd have y squared equals a negative number, which doesn't work. So it would have to be 0 to 1. Perfect. Zero to 1. What is the larger function with respect to x? Remember, it's a function of x.
Two x minus 4 squared. It's 4x. Let's get rid of 4x.
What is the smaller function? Not for 0 to 1.
-2 squared.
Negative 2 root x. Okay. Or in this case, you could also use symmetry. There's the x-axis. Isn't that region symmetrical about the x-axis? So wouldn't the total area be twice the area of the upper half? So I could also just do this, which is going to have the exact same effect. As if you did 2 root x minus negative 2 root x. You get 4 root x, which is twice that integral. Plus area of the second region. What's the larger function?
Square root of 4x.
What's the smaller function?
2x minus 4.
There's the area setup. Simple antiderivative for root x. Now, what about the second? Thirds x what? So the first piece goes from 0 to 1. The second piece goes from 1 to 4. Four times 2/3 is 8/3. Oh, no, this one's easy. That's just 1. So 8/3 it is. I like it. Plus 4/3. What is 4 to the 3 halves? It's 8. Square root of 4, and then cube it. What is 1 to the 3 halves? Well, that's easy. 1. 8 minus 1. Minus, what is 4 squared? 16. Minus 1 squared? 4 times, or just 4 minus 1 is 3. Eight plus 28. 36 divided by 3. Oh, that's nice. 12 minus 15 plus 4 times 3. Four times 3 is 12. Negative 3 plus 12. Area is 9. Now let's do it the easier way. Instead, let's recognize that this region is probably easier to define as functions of y instead of x. Then what is that first function? What about that second function? Right, that's 2 plus y over 2 or y over 2 plus 2, doesn't matter. Points of intersection. This one's a bit of a pain. It's because we have fractions involved. clear out the fractions at the very least. Y squared plus 2y, or minus 2y minus 8 is 0. How does that factor? Which is the larger function? What is the simple antiderivative? I decided I didn't want to save any of that. 4 minus negative 2. Four squared. Negative 2 squared. 16 minus 4.
12.
Oh, look at that. 12 over 4. This is 3. I'm going to write this as 12. 4 cubed. Negative 2 cubed. 64 minus negative 8. What is it? 72 over 12. 12 plus 3, 15 minus 6. The whole point of this problem was to show that sometimes it might be easier to do it with respect to one variable versus the other. And also to show you that you may have to split your region. It may be the case that it doesn't matter whether you do it with respect to x or y, you're going to have to split it, regardless. At which point then you pick your poison. Oh, by the way, looking at these is going to be very good practice for Calc 3. Just a FYI. Just ask my Calc 3 students now. Ooh, what do we do today? We do Stokes theorem today. Oh, I'm excited. We will pick up here then on Thursday. Oh! So don't forget, fourth project is due on the 5th. Exam 3 bonus is up. It will be due before our exam. The exam is scheduled for December 19th, 2:45 to 4:45 in this room.